So today we will demonstrate what is the BLAST program, which is available on the NCBI National Center for Biotechnology Information. So here is the BLAST link on the NCBI website. When we click this, the BLAST web page is open. On this web page, there are the four different types of the BLAST are shown. First is the nucleotide BLAST, in which the nucleotide query sequence is used to search against the nucleotide database, nucleotide subject database. In case of the BLAST-X, we search the translated nucleotide sequence against the protein database. In case of T-BLAST, the protein sequence is searched against a translated nucleotide database. And the commonly used BLAST P, known as protein BLAST. In this case, we use a protein query sequence to search against a protein database. In today's demonstration, we will use this BLAST P to search a protein query sequence against a non-redundant protein database. So we search this protein BLAST link, and the protein BLAST page is opened. So here is on this BLAST page, here is the box. In this box, we can enter the query sequence. We can enter its accession number, or we can paste its FASTA sequence in this box. Or the third option, we can upload a file which contains that protein sequence. So we use this option, and we choose a file in which we have stored a protein sequence. So we search for where our protein sequence file is located. It is located on the desktop. So in the desktop, this here is our the desired file containing a protein sequence of the gene LACS1 Arabidopsis. So we have double clicked that file, and now that file is shown here. So our protein sequence is now available on the BLAST page. Then in the next step, we select the database against which we have to search this query sequence. So commonly we use the non-redundant protein sequences, and this protein sequence database is the most comprehensive, and it contains non-identical protein sequences, and it is updated on daily routine. It is updated routinely. Then we select the organism in the subject organism against which we have to find or search that protein sequence. So in this example, we will search a protein sequence, our desired protein sequence, which we have taken from the Arabidopsis thaliana. And this query protein sequences will be searched in Gossypium, hirsutum, non-redundant protein sequences. So in this arrow, in this box, organism box, we can enter our subject organism. Our subject organism in the today example is the cotton, whose botanical name is Gossypium hirsutum. So we can write in this box Gossypium hirsutum. So when we have just written Gossypium hirsutum, here is the options they are shown. So Gossypium hirsutum, it is on the number 5th. So we can select this, and this organism is shown now in the box. So this has the text seed ID 3635. So after the selection of the organism, subject organism, we have to select the algorithm. So it is already circled, highlighted here, that we will use the BLAST P, the protein BLAST, and we will search a protein sequence of a protein from the Arabidopsis thaliana against the Gossypium hirsutum non-redundant protein sequences. So after doing these steps, we just press the blast button shown here. So we press the button blast, then the program, it starts the analysis. So it will take few seconds. After a few seconds, the result page up, uh, will be uploaded on the screen, will be visible on the screen. So it will take a few seconds. So now in this case, our query sequence is a protein sequence from Arabidopsis, and we have to find a protein. We want to find a similar protein in the Gossypium, hirsutum, non-redundant protein sequences. So this program, it will do the analysis and it will take few seconds to complete the analysis. So here, periodically, the time left to finish the analysis is shown. So now it shows that it will take about 22 seconds more. So now the upper job title, its detail is given here. The request ID, our request, it has given a name by the program, that is F946X1DE014. So this is our request ID. So if we have to find the information about this, we can use this request ID, and its total information will be available on the BLAST website, and it is maintained for about 24 hours on the BLAST page. So the analysis is going on. It may take a few more seconds. It may take about 30 seconds more, then the results will be updated. So the analysis has come to an end, and now the result page is shown. And this result page, it contains first the information about our query sequence, and our query sequence ID is 82G47240.1. The research our request ID is shown here. Then the program which we have used for the analysis, that is the BLASTP protein blast, and the database against which we have searched the query sequence. The subject database, it was non-redundant protein sequences. So the description of our query sequence is 82G47240.1, and the molecular type, it was a sequence of amino acids, and the length of the sequence was 60 amino acids. This is the total information about our query sequence. Then there is the descriptions of the results are shown here. In the description, sequences producing significant alignments, they are shown here, and 100 sequences, they are selected. So this is the descriptions of the subject sequences. First one is the predicted long chain acyl CoA synthetase 1, like a Gossypium hirsutum, and the maximum score is 993, and the total score was 993. The query cover, 99% of the query sequence was covered by this subject sequence during the alignment. The E value, which is the most important expectation value, is zero point 0. The lowest is the expectation value, the more authentic is the alignment. The percent identity in this case is 70.41%. So this is the highest similar sequences which are found in the non-redundant protein sequences of Gossypium hirsutum, and in the descriptions above, there are 100 sequences, they are selected. Then we can also have the graphic summary. This graphic summary is shown in this form. This is the our query sequence, and this is its amino acid number 1 up to amino acid 660. So this is the our query sequence shown here. And then our subject sequences, 100 subject sequence, they are shown. Number first one is the from 1 up to 660. So this has about 70% identity with the query sequence. So the total 100 sequences, they are shown in this graphic summary. So we can also look the alignments of the query sequence with the subject sequence. The first subject sequence, its alignment is shown here. The query sequence amino acid number 1 up to amino acid 60 is shown in this line. Then this query sequence is aligned to the amino acid number 1 of the query sequence is aligned against the fourth amino acid of the subject sequence. So the subject sequence is shown from the amino acid number 4 up to amino acid 63 in this first line of the alignment. So the one by one, the subject sequences, their alignment is shown in this. So this was the first alignment. Then is the second alignment of the second subject sequence with the query sequence, and so on up to 100 subject sequences. Their alignments are shown here. So this will give the authenticity, the alignment statistics. From the alignment statistics, we can select which one is the best matched sequence with the query, which is the best matched subject sequence with the query sequence. So the BLASTP, it is used to search a protein query sequence against a protein subject database.